So if power developed by a turbine in a certain steam power plant is 1200 kilowatt, heat supplied to boiler is 3360 kilojoule per kg, the heat rejected by the system to cooling water is 2520 kilojoule per kg, and feed pump work required to condense it back into boiler is 6 kilowatt. Then the mass flow rate through the cycle will be. So in the question it is given that the power developed by turbine, that is the work done by turbine, is 1200 kilowatt, and the heat supplied to boiler, the amount of heat added at constant pressure to boiler is 3360 kilojoule per kg. The heat rejected by system to cooling water, the amount of heat rejected by condenser at constant pressure is 2520 kilojoule per kg. And the feed pump work, the amount of work required by pump to compress the water that is coming from condenser is 6 kilowatt. And what will be the mass flow rate to the cycle? So WT is 1200 kilowatt, WP is 6 kilowatt, Q1 is 3360, and Q2, amount of heat rejected, is 2520 kilojoule per kg. So from first law of thermodynamics, we know summation of W equal to summation of Q. So here the net work is WT minus WP, and the net heat is Q1 minus Q2. So 1200 minus 6 equal to mass into 3360 minus 2520. So the mass flow rate through the cycle is 1.421 kilojoule per second. So next question. An electric power plant produces 10 megawatt of power, consuming 90 into 10 power 6 kilojoule per hour of fuel energy. The heat rejected by the power plant is. So in the question it is given, electric power plant producing power, that is work done by turbine, is 10 megawatt. If we convert into kilowatt, it will be 10 into 1000 kilowatt. Consuming 90 into 10 power 6 kilojoule per hour, that is the amount of heat added. 90 into 10 power 6 kilojoule per hour. So we need to convert this into kilojoule per second. Kilojoule per 3600 second. So we need heat rejection. So here WT equal to Q1 minus Q2. So Q2 equal to Q1 minus WT. 90 into 10 power 6 by 3600 into 10,000. 25,000 minus 10,000 equal to 15,000 kilowatt, that is 15 megawatt.